So I'm going to introduce ChanceCalc for doing the arithmetic of uncertainty. Now, if I told you what the mathematicians call this, it would trigger post-traumatic statistics disorder, or PTSD. But the basic idea is you got all kinds of uncertainties which can now be stored in the cloud, uncertainties from authoritative sources, by the way. And you can run this through ChanceCalc and find out the chance of being beyond budget, below projection, or behind schedule. So let me give you a simple, concrete example of this. We're producing software to run an e-commerce site, and we need the customer accounts and the products and the orders and the fulfillment. These are completely separate programming tasks that each take on average 10 weeks. And of course, we're not going to go live until all 4 of them are done. We're not certain about those 10 weeks, so the boss comes in and says, what's the chance we're actually going to go live in 10 weeks? And at that point, you say, like you're asking me how many angels would fit on the head of a pin. I mean, we certainly don't answer those. We don't even ask questions like that. So now I'm going to define the arithmetic of uncertainty. Arithmetic, you're probably familiar with. It tells us that x plus y equals z. The arithmetic of uncertainty says, what do you want z to be? Here are your chances. This is what ChanceCalc does. I select the uncertainties. I click on this button, and up comes a browser to what we call the SITMath network. And I'm going to grab the development time library. It's got the time to finish the accounting software, the product software, the orders, the fulfillment, all those different components, and they're being done in parallel. So I click on that, and now suddenly we have uncertainties in these cells instead of single numbers. And for example, imagine 1,000 parallel universes. So, there's trial 1, trial 2, trial 3, which is a separate universe. I can also look, for example, at the average durations. Those are all 10 weeks, of course, and I can do this in my head. The maximum of 10, 10, 10, and 10 is 10. But remember, if any one of these goes beyond 10, it delays the entire project. So now the question is, what's the chance we're done in 10 weeks or less? And so I put a little symbol in there like that. You've seen that someplace. There's a 10. And now I just pop up the chance of whatever button. And I want to know the chance that that thing bears that relationship to that thing. And the answer is 12%. And you can't do that in your head. And what's going on in the background is this is a native Excel file. There are no macros in here. It's just looking at all thousands of possibilities and saying, for which ones did you finish in 10 weeks? Turns out like 12% of them. Oh yeah, what would happen if that were like finishing in 12 weeks? Well, that's 34%. What would happen on average? What do I mean by that? I mean, if you could repeat this situation over and over again, what would the average finish time be? We're learning a new button here, the average button. I click in that cell. That's our go live time. Oh my gosh, it's 15 weeks. So now we see the flaw of averages in all its glory. That is, you plug in all your average assumptions of 10 weeks and you're done in 10 weeks. Right. On average, you're done in 15 weeks. This is just not close enough even for government work.